Hi, we're still looking at this problem. Now I'm going to solve part B, which is after we have got the equation of motion. We want to find the characteristic equation and solve for the natural frequencies. So once we get the equation of motion, then we actually substitute all the values, and the next step is we want to assume solutions so that we can collect all the terms in terms of capital X and capital theta. So after we have the assumed solutions, you can actually substitute into the matrix. So after you have assumed the solutions, so in this case, I assume it to be x equals to x sine omega t and theta equals to capital theta sine omega t. You can also assume it as cosine, no problem, as long as it's a harmonic motion. We assume harmonic motion, and because later on these sine functions we're gonna factorize and divide with 0, so you're going to cancel out anyway. So then you get x double dot and theta double dot. Okay, so this one you already substitute, so this part here is actually your x double dot, and this one is actually your theta double dot. Okay, so you can see that all the expressions, okay, let me just erase some of the, you can see that all of the expressions has sine omega t, isn't it? So you can actually factor it out and bring it to the other side of the equation. So 0 divided by sine omega t, you will actually get 0 as well. So you can see you will end up with only capital X and capital theta, basically. So that's why you can simplify it as such. So basically you factor it out and you bring your negative omega. If you times this with this, so you end up with this expression basically for the omega, negative omega square, same as for this one. Yeah, so you end up with this expression. So in matrix, since you have x and theta is a common vector, you can just add them up. So that's why you have negative 20 omega square plus 15,000 here. So basically you just add element by element. So this one is 0. So that's why you just have negative 50 here. So you get it from this expression. So after you rearrange, then the next step is you want to get the determinant. So if you remember, the equation for determinant is AD. If I name it as A, B, C, and D, so basically AD minus BC. So if you times that up, so if you actually expand it, so I already did this. Basically, this is your A times D minus B times C. It's a very large number, but it's okay because the right hand side is 0, so you can actually divide all through with the same number. Yeah, so if you factor it out, or you make all the numbers divided it in with the same values, so and so you can get a smaller coefficients. For example, here I divide all through so that the coefficient of omega 4 is equals to 1. So this is actually the answer for part B. So, and this is what we call, so this is what we call the characteristic equation, which what they want us, what the question wants us to find. Okay, so next is we want to find the natural frequency. So you can actually use the quadratic formula, or you can also use your calculator. So maybe in the calculator you have to change mode into the polynomial equations for to the power of 2. So you can see that A is basically 1. Okay, the coefficient, the second coefficient is B. Okay, and the third coefficient or the constant is actually C. So from there you can actually get your results, and your results are actually in terms of square, yeah, to the power of 2, because this equation is to the power of 4 basically. So you may want to get the final answer, you have to get the square root of that answer. Okay, so you have to take square root of this answer and that answer in order to get omega 1 and omega 2. So okay, so that's all. I think we've done with the whole solutions for these final exam questions. The first step is we get the EOM for 2 degrees of freedom system. You can also watch a video on how to derive that. So once we get the equation of motion, put it in a matrix form, have the assumed solution and substitute, get the determinant and solve for your characteristic equations, and finally you can get your natural frequencies. Okay, that's all for this video. Thank you.